Now we're going to talk about parallel and perpendicular lines. So parallel lines are two lines that will have the same slope, but they will not intersect. So we see like if it has -2, -2x plus 6, -2x minus 4, those are examples of parallel lines. They have the same slope, but they do not intersect or parallel. If they have different slopes, they will intersect and they are not parallel. This is an example of perpendicular lines. These are two lines that form a right angle. So they have a special relationship between their slopes as well. So I'll summarize it here. Two lines are parallel if they do not intersect. The slopes of the lines are the same. If m1, that m being the slope, m1 times x plus b1 and m2x plus b2 are parallel, they're parallel if m1 equals m2. If and only if b1 equals b2 and m1 equals m2, we say that they're the same line. So if they're coincident. I don't know how valuable that part is, but that was in the book. Okay. Two lines are perpendicular lines if they intersect at right angles. If f of x is m1x plus b1 and g of x is m2x plus b2, they're perpendicular if m1 times m2, the product of the slopes, is -1, or m2 equals -1 over m. That should be an m1. There we go. Much better. So given the functions, identify the functions whose graphs are a pair of parallel lines and a pair of perpendicular lines. So what I'm looking through here looks like f of x being 2x plus 3 and j of x being 2x minus 6. They both have the slope of 2. So f of x and j of x are parallel. Then if we look at g of x and h of x, so we have the slope of 1/2 versus -2. These are negative reciprocals, so g of x and h of x are perpendicular. So how to write the equation of a line parallel to the given line that passes through a given point. So find the slope of the function, substitute the given values into either the general point slope formula, general point slope equation, or the slope intercept equation for the line, and then simplify. So let's see. Find a line parallel to the graph of f of x equals 3x plus 6 that passes through 3, 0. So our slope here is 3. So m is 3, and then the point is 3, 0. So we have y minus y1 equals m times x minus x1. That's a point slope formula. So y minus 0, the y1 is 0, equals 3 times x minus 3. So y equals 3x minus 9. That's it. That's kind of fun. How to write the equation of a line perpendicular to a given line and passing through a given point. So find the slope of the function, determine the negative reciprocal of the slope. So we flip it and change the sign. And I can delete that. Okay. Substitute the new slope and the values for x and y from the coordinate pair provided into g of x equals mx plus b. Solve for b. Write the equation for the line. So here we have the line that it's going to be perpendicular to, has a slope of 3. So m1 is 3, which means m2 is the negative reciprocal, or -1 over 3. And it's going through that same point, 3, 0. So y minus 0 equals -1/3 times x minus 3. So that means y equals -1/3 x minus a negative, so I'll write like this, minus -1/3 times 3. So realize that this double negative makes that to a plus. So y equals -1/3 x plus 1. Okay, how to write the equation of a perpendicular line that passes through a point. Again, determine the slope of the line passing through the points. Find the negative reciprocal of the slope. Use a point slope or the slope-intercept form or point slope form to write the equation by substituting the known values. Then simplify. So here we have to find the slope. So and we want to be perpendicular. So our M1 is going to be 5 minus 6 over 4 minus negative 2, or negative 1 over 6. So M2 is the negative reciprocal. It means we're going to flip this and change the sign. Remember, in perpendicular slopes, one's positive, one's negative. So we're going to flip it and change the sign, so it's just 6. And the point we're going to go through is 4, 5. So y minus 5 equals 6 times x minus 4. 4 is the x value. 5 is the y value. So y minus 5 equals 6x minus 24. And we can add 5 to both sides. So y equals 6x minus 19. Okay. And we will pause there.